Imagine a massive dark shape skimming just 10 feet above the freezing ocean surface at 250 miles per hour, or looking up to see a giant mechanical skeleton lifting an entire house through the clouds. Have you ever wondered how these extreme and bizarre machines could ever leave the drawing board and actually take to the sky? Today we are going to strip away the engineering secrets behind the 10 most bizarre classic aircraft in aviation history. Stay with me until the very last moment, because the number one entry is a creature that looks like it escaped straight out of a science fiction nightmare. And if you haven't subscribed yet, hit that button right now so you never miss a single thing that comes next. Starting off our countdown at number 10 is the Fokker Dr.I, Germany's legendary mechanical nightmare introduced in 1917. During the bloody dogfights of the First World War, engineers faced a brutal battle for ultimate turn-fighting agility. Their solution was powered by an Oberursel rotary engine producing 110 horsepower. Unlike modern engines, the entire massive engine block spun with the propeller. It created an iconic asymmetric clattering sound and generated immense gyroscopic forces that violently pulled the 2,000-pound plane to the right side. Visually, engineers bolted 3 stacked wings onto a single fuselage, making the aircraft jut out like a desperate flying wooden staircase painted in bright, intimidating colors. This bizarre triple-wing design sacrificed top speed, which maxed out at only 115 miles per hour. But in return, it gave the aircraft an unmatched, terrifying rate of climb and agility. In its practical application, it became the ultimate WWI dogfighter, allowing ace pilots to outmaneuver almost anything in the sky, turning tightly inside the radius of conventional British and French biplanes. However, there is a dark mechanical reality here. This pursuit of extreme agility came with a deadly structural flaw in the upper wing drag cables. In steep, high-speed dives, the aerodynamic pressure was so intense that the upper wing fabric would literally tear off. Leading to catastrophic mid-air disintegration, it was a near-death reality for every pilot, including the infamous Red Baron. But if stacking 3 wings seems like a desperate, fatal move, wait until you see the flying wooden scaffold sitting at number 9. Enter the Caproni Ca.3, a heavy bomber built by Italy in 1915 to fight a brutal battle for heavy payload capacity. To get this massive 7,200-pound wooden structure off the ground, engineers relied on 3 enormous Isotta-Fraschini engines, each producing 150 horsepower. 2 engines pulled from the front, while a third engine pushed from the rear. The result was a chaotic, unsynchronized, deafening roar. It shook the bones of anyone flying it at its maximum speed of 85 miles per hour. When you look at the Caproni, it visually looks less like an airplane and more like a massive construction scaffold with a canvas cage bolted onto it. It featured a bizarre twin-boom tail holding the entire flimsy structure together. In terms of practical application, it was a pioneer of early strategic heavy bombing. The Italian military used this sprawling, slow-moving target to carry up to 1,700 pounds of bombs deep into enemy territory, unleashing destruction while flying barely higher than the mountain peaks. Now, look closely at the rear of this bizarre machine to find its most terrifying flaw. To defend the aircraft, the rear gunner had to stand completely exposed in a flimsy open-air basket, perched directly above the spinning wooden blades of the rear pusher propeller. They were dodging enemy anti-aircraft flak, while praying a sudden jolt did not send them falling backward into the deadly blades. That was a monster of the First World War. But the next aircraft took the shape of a pregnant water bird. At number 8 is the Grumman J2F Duck, deployed by the United States Navy in 1936. This machine was the answer to a highly complex amphibious rescue puzzle weighing in at nearly 5,500 pounds empty. To power this heavy beast out of rough waters, it was equipped with a rumbling 900 horsepower Wright Cyclone radial engine. It could reach speeds of 190 miles per hour, a respectable number for a machine that had to fight the massive drag of its own hull. Grumman's engineers untook a massive bulbous central pontoon and awkwardly blended it directly into the main fuselage. Visually, it looked heavy, bloated, and entirely unaerodynamic, earning its nickname as the ugly duckling of the fleet. Yet, in practical application, there is a hidden brilliance to this deformed shape. The lower section of that massive chin pontoon actually housed a watertight cabin that could fit a stretcher and a medic, making it an incredibly durable utility in rescue aircraft for plucking downed fighter pilots right out of the freezing ocean. The brutal reality of flying the Duck involved horrific bone-jarring impacts. Rescue crews purposefully slammed that massive pontoon into 10-foot ocean swells in the dead of night, trusting the heavy riveting to hold together. Test pilots reported near-death experiences during rough landings, where the immense water drag nearly flipped the aircraft end over end. It was hideous, but it was a mechanical hero built for punishment. If the Duck was strangely shaped for water, the aircraft at number 7 was deformed for hunting submarines in the dark. Say hello to the Fairey Gannet, introduced by the United Kingdom in 1949. The British military needed the absolute reliability of 2 engines for long maritime patrols, but they only had room in the nose for 1. Their solution was the Armstrong-Siddeley double Mamba engine, pushing out over 2,900 shaft horsepower. It took 2 independent turbine engines, shoved them into a single housing, and drove contra-rotating propellers, propelling the 10,000-pound aircraft to over 310 miles per hour over the cold ocean. Visually, the Gannet was an absolute mess. It featured a bulging multi-tiered cockpit that looked exactly like 3 separate glass greenhouses stacked haphazardly on top of a fat Z-folding wing structure. In its practical application, this strange layout was highly necessary. The pilots sat up front, while the radar operators sat in the rear greenhouses, hunting for Soviet submarines. The unsaid brilliant truth of the double Mamba was that both engines drove a shared coaxial gearbox. If one failed, you simply cruised home safely on the other. However, the real nightmare of the Gannet was not aerodynamics. It was the terrifying mechanical complexity of that shared gearbox. Maintenance crews suffered, trying to keep the intricately geared contra-rotating shafts from tearing themselves apart under extreme stress. Furthermore, the sheer noise of the twin turbines, emitting a high-pitched, piercing whine, was known to cause permanent hearing damage on the flight deck. The Gannet was a weird military experiment, but the civilian world produced something straight out of a post-apocalyptic wasteland to take our number 6 spot. At number 6 is the Transavia PL-12 air truck, built in Australia in 1965. This plane was built to haul a massive 2,000-pound hopper of toxic agricultural chemicals safely over the harsh outback. Powered by a sputtering Continental flat-6 engine, producing just 300 horsepower. It struggled to push its bizarre frame through the air at a cruising speed of only 105 miles per hour. It was a purely functional, gravity-defying tractor, meant to work low to the ground in blistering heat. Visually, the air truck literally looks like spare parts from 3 entirely different crashed airplanes bolted together. It features a stubby central pod, completely separated twin tail booms, and an elevated cockpit perched on top. In its practical application of crop dusting, the missing context for this absurd shape is ground safety. The twin tails were separated specifically so that chemical loading trucks could back directly up to the rear fuselage without striking the aircraft, keeping the deadly toxic dust away from the pilot sitting high above the chemical tanks. Due to its extreme unaerodynamic shape, The air truck was notoriously dangerous and tricky to handle. It suffered from severe instability and sudden crosswinds. Pilots often wrestled with the controls just to keep it flying straight. It was so inherently aggressive in its ugliness and strange proportions that it was famously chosen as the villain's aircraft in the movie Mad Max Beyond Thunderdome. Before we cross the threshold into the top 5 most insane machines ever built, remember to hit that subscribe button for more deep dives into heavy machinery. Coming in at number 5 is the Beechcraft Starship, unveiled in the United States in 1989. This aircraft represented an all-out war to defeat aerodynamic drag using bleeding-edge composite materials. Powered by twin Pratt & Whitney turboprops, mounted as pushers at the rear, generating 1,200 horsepower each. It emitted a distinct buzzing thrum, weighing over 14,000 pounds. It was designed to cruise at 380 miles per hour, aiming to revolutionize the high-speed corporate travel market with its composite airframe. Visually, the Starship was stunningly bizarre. It completely abandoned the traditional tail, featuring sweeping main wings with massive vertical tips and futuristic front canards. It looked exactly like an alien spacecraft cruising through corporate airspace. In practical application, it was built for luxury executive transport, offering a spacious, whisper-quiet cabin. Since the roaring engines were pushed far behind the passengers, it was meant to be the absolute pinnacle of sleek modern aviation, replacing loud, vibrating aluminum airplanes with smooth carbon fiber. But here is the critical flaw that killed it. Because carbon fiber construction was so new, federal regulators did not trust it. They forced Beechcraft to drastically over-engineer and thicken the airframe, which destroyed its weight advantage. It became incredibly heavy, sluggishly slow, and ridiculously expensive to maintain. Selling only 53 units, it was a massive commercial failure, choked to death by regulatory paranoia. The Starship failed the corporate world, but our next machine was a Cold War experiment that walked a deadly mechanical tightrope in the sky. Number 4 is the Bell X-22, an American experimental aircraft from 1966. Long before modern tiltrotors existed, Bell engineers attempted to make a 15,000-pound heavy transport plane take off vertically. Powering this complex rig were 4 General Electric turboshaft engines, producing a combined 5,000 horsepower. These engines allowed the bizarre craft to hover completely still, or reach a top forward speed of 250 miles per hour. It was a massive, deafening mechanical beast, attempting to conquer the vertical takeoff and landing puzzle. Visually, it completely abandoned standard wings. Instead, the X-22 had 4 massive tilting ducted fan barrels mounted on a short, stubby fuselage. In practical application, it was a highly advanced military testbed. The goal was to prove that troops and heavy cargo could be rapidly deployed into tight jungle clearings without needing a runway. Combining the speed of a traditional airplane with the hovering capability of a helicopter. The ducted fans were heavily shrouded to increase lifting efficiency and protect ground crews from the spinning blades. However, the mechanical insanity lay beneath the skin. The engines did not directly drive the fans they sat next to. Instead, they fed into a centralized, incredibly complex web of high-speed drive shafts. The transition from vertical hovering to horizontal flight was an absolute terror. Test pilots fought deadly, violent mechanical vibrations that constantly threatened to shatter the drive shafts mid-air. One wrong resonance frequency, and it would tear itself apart. If 4 giant tilting fans were not crazy enough, imagine a screaming helicopter with absolutely no body at all. At number 2 is the A-90 Orlyonok, a top-secret Soviet project from 1972. This was an achronoplan, a massive 300,000-pound machine. Built to ride the ground effect cushion of high-pressure air just above the water, to evade NATO radar. To move this steel mountain, it relied on a massive Kuznetsov turboprop howling on its tail, producing 15,000 horsepower. It blasted across the freezing ocean surface at an incredible top speed of 250 miles per hour, hovering just 10 feet high. Visually, it was a terrifying mechanical sea monster, half naval ship and half airplane, painted in stark military gray. In its practical application, it was designed for high-speed amphibious Soviet assaults. It could carry over 150 fully armed Marines, or 2 heavy battle tanks directly onto an enemy beach, completely undetected by conventional ship radar. But the missing data is in the nose. It actually hid 2 massive turbofan jets buried up front, used exclusively to blast high-speed exhaust under the wings to break the water's brutal suction. It was an incredibly dangerous machine to operate. In 1975, during a high-speed test run, the hull struck a rogue wave, and the entire heavy tail section ripped completely off. In a sheer display of terrifying pilot grit, the captain managed to throttle the hidden nose engines and literally drove the wingless, mangled fuselage back to the naval base like a shattered speedboat. The Orlyonok was a Soviet giant. But the American machine sitting at number 1 is the ultimate gravity-defying behemoth of aviation history. Number 1 is the Aerospace Line Super Guppy turbine, taking flight in 1965 to fight the mechanical battle of the space race. NASA had to move massive Apollo-Saturn rocket stages, and trains were simply too small, weighing over 100,000 pounds empty. 4 Allison turboprops shrieked in agony, producing nearly 20,000 horsepower to push this aerodynamic nightmare through the air. It was a desperately slow beast, maxing out at 280 miles per hour while fighting an unbelievable amount of atmospheric drag. Visually, the engineers took a thin vintage bomber tail and bolted an impossibly swollen bulbous whale forehead right onto it. The scale is incomprehensible until you actually stand next to it. The cargo bay is 25 feet in diameter and incredibly cavernous. In practical application, this massive bay was hinged to swing completely open, allowing crews to slide entire space station modules and rocket boosters directly inside. It could easily swallow a complete 2-story suburban house, roof and all, directly into its gaping mechanical maw. It was a terrifying aircraft to pilot. The Super Guppy was incredibly dangerous to fly in heavy crosswinds because the massive side profile acted like a giant sail, threatening to flip the plane out of the sky. It was structurally ridiculous and deeply flawed. Yet, and without this bizarre flying whale, NASA could never have transported the delicate rocket components across the country in time. Without the Super Guppy, America might never have successfully reached the moon, proving that sometimes the strangest designs achieve the greatest triumphs in human history. These machines weren't just crazy designs, they represent raw engineering pushed to its absolute limits, proving that real solutions to impossible problems often look like complete madness. Which of these flying oddities did you find the strangest? Which one would you want to see fire up its engines in person? Is there a bizarre aircraft I completely missed? Tell me in the comments. Drop a like, subscribe, and ring the bell. Every week, there's a new heavy machinery video. See you next time.